with him throughout his life, as we will see later. Okay, microphone has died. So I think that's it for that. I think that tells us probably the battery. Can everyone still hear me if I talk nice and loud?
Sure.
Okay, good. James's family were not particularly well off, far from being wealthy, as he would be later in life. In fact, the wealthiest man in town at that time was actually the town miller, a man named Henry Snavely. So Henry Snavely, town miller, wealthiest man in town. And at some point, James actually fell in love with Barbara Snavely, the miller's daughter. And in 1817, when James is 21, thank you much. So in 1817, when James is just 21 years old, Barbara falls pregnant with his child. Now, James, doing the honourable thing, went to Barbara's father and asked for her hand in marriage. But remember, the miller was the richest man in town, and James was decidedly not. So the miller responded, "Have you a penny in your purse? When you have a mill as large and as costly as mine, you can have my daughter's hand, but not before." Now, as we will come to find out, James was a man of great temper, and so he actually responded, "Someday I will own a mill that will make yours look like a pigsty by comparison." And he stormed out, exactly how you want to deal with your girlfriend's father. So James decided if he was going to marry Barbara, he had to leave to seek his fortune. So he left town intending to become wealthy and return for Barbara. But he didn't actually tell Barbara this, he just left town looking to find his fortune. So he left, he moved to Pennsylvania, where he started to learn the art of piano making. Now remember, his father was a cabinet maker and carpenter. He had taught James everything he knew about carpentry and cabinet making, and so James actually took to it very well. In 1819, he moved again to Baltimore to work for Joseph Hiskey, and his skills as a woodworker really shone through in the pianos that he was able to make. He very quickly mastered the art and moved to New York City, where he set up his own shop. Now, he was very successful, but he noticed that every couple of weeks, the same wagon would show up at his shop, load up with pianos, and disappear. And eventually, James wanted to know where his pianos were going. So one day, he closed up shop early, followed that wagon, and found that it made its way to the port of New York, where his pianos were loaded onto a ship bound for South America. Now, this time, pianos were a status symbol. All of the wealthy households in South America wanted these grand pianos to show off how rich they were. And James, being a shrewd businessman, realized that surely if people were buying his pianos, importing them to South America, and reselling them, presumably for profit, he could make more money by simply moving to South America and cutting out the middleman. And so that's what he did. In 1821, James boarded a ship bound for Buenos Aires in Argentina. Now, Argentina had won their independence from Spain only a few years before this, so the situation was still fairly turbulent, but James was decided, off he goes. He did discover that he hated ocean travel. He became very, very seasick, and of course, the journey here took 4 months at sea. So he had a miserable time, but in 1821, in November, he's 25 years old, and he arrives in Buenos Aires. Sets up his business, and his business, sure enough, flourishes. All of the wealthy people wanted his pianos. He did very, very well for himself. So well, in fact, that just 4 years later, in 1825, he did what all the wealthy people of the day did. He set out for a grand tour of Europe. So in 1825, despite hating ocean travel, he boards yet another ship, heads off for England. He lands in Falmouth, he visits London, he visits the Royal Botanical Gardens in Kew, just outside of London. There they have a conservatory of flowers with plants from all around the world. And this made a lasting impression on James. Remember, his mother had passed on a fondness for horticulture. He moved on to Paris. He visited the Palace of Versailles, where he appreciated the very, very fine woodworking inside.
He continued on to Westphalia in Germany, which is where his family had originally emigrated from. He visits Heidelberg, Hamburg, but eventually, after about 8 months in Europe, he decides it's time to get back to work. So he boards another ship, heads back to Buenos Aires. Unfortunately for James, the Cisplatin War had broken out between Argentina and Brazil, and the Portuguese had actually blockaded the Rio de la Plata, and James's ship is captured. Everyone on board is taken as a prisoner of war to a prison in Montevideo, which these days is part of Uruguay, but back then was still part of the Brazilian Empire. And he's held as a prisoner of war for about 6 months, until eventually one of his fellow passengers dies, and James is assigned to the burial detail. They bury this fellow outside of the prison walls. James takes his chance, he escapes, hides in the brush until nightfall, and then makes his way 20 miles west on foot until he finally encounters the Argentine army. He explains the situation, and they return him to Buenos Aires. In 1832, James decides he's finally doing well enough to return to Stumpstown to visit Barbara and his son. At this point, he is 36 years old, and he's been gone for 15 years, and he never told Barbara of his plans. Now, journalists writing about James's visit stated that he came to Fredericksburg with a horse and buggy loaded down with gold doubloons that he carried in belts about his body, and he brought with him $40,000 worth of valuable South American skins and hides. It's about $4 million worth in modern currency. He really wanted to show off how wealthy he had become. But, perhaps unsurprisingly, he arrives to find that Barbara had married another man just 2 years after he left. This was not the time to be a single mother. So she had actually married this man, John Desch, who was the local cooper and constable. And in fact, upon hearing that James was coming back to town, she left town, and along with James's son, and James never saw Barbara again for the rest of his life. To make matters worse, he arrived to find that his father had actually died the year before. So overall, not a good trip for James, at least not personally, but he did sell those hides and skins for a tidy profit, so business-wise, he's still doing very well. One of his friends and fellow piano maker, Conrad Meyer, wrote at the time about James's plans to settle permanently in Philadelphia. He actually rented a building and paid a year's rent in advance, planning to set up shop and make pianos. But just a few days after his visit to Fredericksburg, he left again to New York and Boston and eventually returned to South America. And of course, now we know exactly why. Barbara had married another man, his father had died, there was nothing left for him in North America. So James heads back to Buenos Aires, but when he arrives, he finds the city is in a state of civil unrest. There's rioting, there's looting. He decides he's not going to deal with this. He packs up shop and decides to move to Chile. So he decides he's going to move to Valparaiso in Chile. Before he leaves, he buys 2 large millstones in Buenos Aires for about $3,000. Despite the whole Barbara situation, he is still intent on building his mill and proving the miller wrong. The ship that he's traveling on travels around Cape Horn, where it encounters severe storms, almost capsizes, but it is kept upright by the weight of those millstones that James had purchased down in the cargo hold. And then when he arrived in Valparaiso, he ended up selling those millstones for $7,000, again making a nice tidy profit. Valparaiso was stable for a few years, but eventually there was civil unrest starting there as well, and James, having seen what happened in Buenos Aires, decides he's having none of it. He moves yet again in 1835 to Lima in Peru. At this point, he is 39 years old. He's living in his 3rd South American city, but he finds he really enjoys it. At this time, there were about 100,000 people living in Lima, and James finds he really enjoys living in the economically and politically powerful city. His business continues to perform well. He ends up investing in a number of enterprises, including a number of fruit orchards outside of the city. And in 1838, he meets his neighbor and lifelong friend, Domenico, who again we'll come back to later. Now, James spent 11 years in Lima, but eventually, in 1846, he hears about the Mexican-American War. And he knows the US had never ceded territory in war, so he decided this would be a great growth potential opportunity for America. He decides he's going to move back to North America, and he identifies a small town, Yerba Buena. It has a good harbor, and there's good potential for growth. His friend, Mr. Foster, actually said to James at the time that the United States would not acquire California, and that in any case, the inhabitants of California were a set of cutthroats who would simply murder him for his money. Wonderful view of Californians. But James knows best, and so he wanted to sail to Yerba Buena immediately in 1846, but a large portion of his workforce, who were mostly Mexican workers, had actually quit to go and fight against the US in the war. So James spent another year and a half in Lima, finishing up his outstanding piano orders. Finally, in 1847, he's ready to leave. Before he leaves, Yerba Buena is renamed San Francisco. And he then boards the Lady Adams and sails north just before Christmas in 1847. He's 51 years old at this point, and he's finally returning to North America. Sure enough, just a few months after he lands in January of 1848, the Treaty of Guadalupe Hidalgo is signed, and California officially becomes part of the United States. Upon arrival in San Francisco, James brought with him his workbench and all of his tools. These actually still exist and are on display at the Lick School in San Francisco. He brought with him $30,000 of Peruvian gold doubloons, fully half the value of his business. He was so desperate to return to North America and the growth that he expected to come there, he sold his business for less than it was worth. But this is about $3 million worth as of 2020. And he brought with him 600 pounds of Guatemalan chocolate from his neighbor and friend Domenico, with the plan to sell it on consignment in this new city. When James arrives, the population of San Francisco at that time was just about 800 people. Wow. Quite a step down from Lima, with its 100,000 people. But James is sure there is growth to be had here. So he buys a solid building in town with a basement, buries his gold in a chest underneath his basement floor, and sets about life in San Francisco. Now, James arrived January 7th of 1848. So some of you may know what happened just a few weeks later. Gold is discovered at Sutter's Mill, January 24th of 1848. Now, like most people, James tries his hand at prospecting. He heads out to the gold fields, spends a few days digging, finds nothing, and returns to San Francisco, declaring that his money will be made owning land rather than digging in it. People in San Francisco at this time are desperate to sell their land to fund a prospecting stake, and as the man in town with all the money, James is more than happy to buy your land from you. Upon arrival in the bay, entire crews of ships would just abandon their ships to head off to the gold fields. The bay filled up with ships. You could reportedly walk from one ship to the next to get to shore without ever getting your feet wet. And through all of this, James continues to buy up land and buy up land. when you return from the goldfield, he's more than happy to sell your land back to you, but reportedly at 1/10 of the lot size for 10 times the price he paid you for it. He very quickly became very wealthy and also ended up owning about half of San Francisco at this point. San Francisco became a boom town. James found he had no trouble selling all of that chocolate that he arrived with, and so he writes to his neighbor, Domenico Ghirardelli, back in Lima, Peru, telling him to come north to California and assuring him he'll have no trouble selling his product in California. Sure enough, Domingo Ghirardelli heads to California, and by this point, James actually owns a good chunk of San Francisco and ends up gifting Domingo Ghirardelli his first premises in San Francisco. So it is thanks to James Lick that we have Ghirardelli here in the Bay Area. Now, the gold rush brought people into the area from all over, and the population of San Francisco exploded to more than 20,000 people in just 2 years. And through all of this, James continues buying up land wherever he can get his hands on it. Finally, in 1855, James gets around to building his mill. He has held on to this grudge for all of these years. So he builds a mill, he equips it with hardwood floors, brass fittings, and even installs crystal chandeliers inside this mill. He took a photo of it and reportedly sent it back to Stumpstown, even though Barbara's father was likely long dead by this point. He had made a promise, he had held on to this grudge, he had fulfilled it. Now, the mill was extremely extravagant, and while it did reportedly grind some very fine flour, it was simply never profitable. He had sunk too much money into this. He had spent about $200,000 of his fortune building this mill, and people at the time never understood why he had spent so much money on this, and they referred to it as Lick's folly. Of course, now we know exactly why he built it. The mill was eventually destroyed in a fire in 1882, but the round granary building that James had designed to be rodent-proof actually still stands today just off of Montague Expressway on the aptly named Lick Mill Road in San Jose. Also in 1855, James's son, Jon Lick, came to California at James's invitation. Now, he worked for a while as a notary in San Francisco, but the two never got along. James was very headstrong, and he thought that Jon was lazy and work shy, and Jon thought that James enjoyed extravagance and the trappings of wealth too much. And so after just a couple of years in California, Jon Lick headed back east, and the two never reconciled. Now, despite having built a 24-room mansion next to his mill in San Jose, and having built a grand hotel in San Francisco, the Lick House Hotel, reportedly the finest hotel west of the Mississippi at the time, James actually preferred to spend most of his time on his homestead in the Santa Clara Valley. He had many orchards there. He was actually responsible for introducing eucalyptus trees to the area in an attempt to limit the effect of the Guadalupe River flooding. And he even went as far as importing soil with these trees all the way from Australia, because it was unknown how they would react to the California soil. Of course, now we know they love it. You can blame James Lick for the eucalyptus trees in the area. And it was around this time in 1860 that he met this man, George Madeira. Now George Madeira was a mining engineer who had come to California during the gold rush, but he also had an interest in astronomy. He owned a small portable telescope, and he would travel around the area giving lectures to the public. In 1860, James had attended one such lecture that George Madeira gave in San Jose, and he invited George back to his homestead to spend a few nights looking at the night sky. As a little aside here, the first observatory constructed in California was actually made by George Madeira, just outside a volcano. He set up a small 3-inch refractor and used it to observe, among other things, the Great Comet of 1861. But it was while staying on James's homestead that George Madeira made the comment, "If I had your wealth, Mr. Lick, I would build the world's largest telescope on that mountain." Now, we don't actually know what mountain he pointed to. It could have been any of the mountains visible from James's homestead, one of which is Mount Hamilton. Now, James Lick became increasingly eccentric in his old age. He cared nothing for his personal appearance. He would often be mistaken for a tramp on the side of the road as he would travel around in his wagon picking up roadkill. People didn't know he would actually grind the bones up to make bone meal to fertilize his orchards. They just saw a tramp on the side of the road. He was very, very stubborn. He would test his employees' obedience by telling them to do things like plant trees upside down, and if you questioned him, that's it, you were fired. He stranded a group of ladies in his fields one day when they dared to say that they had seen prettier violas in San Francisco. His eccentricities were even the subject of newspaper articles. There's a little excerpt there from an article in the San Francisco Chronicle. But it was actually thanks to James's irritable whims that San Francisco would get one of its great buildings. So, if you remember, when on his grand tour of Europe, James had visited the Conservatory of Flowers at the Kew Gardens just outside of London, and he decided that he would purchase a replica for San Jose. After purchasing that conservatory for San Jose, before it arrived, the local newspaper ran an article about James's eccentricities and his strange mannerisms. James decided the city no longer deserved his gift, so it actually sat on the dockside for many years until after his death, when a group of San Francisco businessmen purchased it and set it up in the Golden Gate Park, where it still stands today as the Conservatory of Flowers. So James's pettiness and his ability to hold a grudge led to the Conservatory of Flowers in Golden Gate Park. Now, in 1873, at his homestead, James suffered a stroke, and it was actually his assistant, Thomas Fraser, who discovered him lying on his kitchen floor, promptly got him to a doctor, which saved his life, but James would now require constant care. So he was forced to move to a set of rooms at his hotel in San Francisco. Now, realizing that his health was rapidly declining, James started to think about what he wanted to do with his fortune. Remember, he did not get on with his son. He certainly wasn't leaving his money to Jon Lick. He wanted to be remembered. He wanted a monument to himself. And so there were a few people that had a large impact on his thinking, one of whom was George Davidson. Now, George Davidson was a geographer and also president of the California Academy of Sciences, and he was a good friend of James Lick. He was also an amateur astronomer. He had set up a telescope in San Francisco, which he had used many times with James, and so you can see where this is heading. James is surrounded by astronomers. He wants a monument to himself, and so his first idea, giant statues. Giant statues of himself and his parents built in the Golden Gate Harbor for people to see from miles around. Eventually, someone pointed out these would likely be used as rangefinders for any naval bombardment during a war. Not good for a monument. James decides, okay, something else. New idea. Giant pyramid. Giant pyramid bigger than any in Egypt, which he would be buried in. But where do you put a giant pyramid? Well, if you're James Lick, you put it on 4th and Market Street in San Francisco, a city block that you own the entirety of. Again, someone eventually pointed out that this might be a bit of an eyesore, people might not appreciate it, and so James returned to the idea of building an observatory, likely influenced by his friends Davidson and Madeira. And in an excerpt from the Lick Deed of Trust, you can see he makes mention of a powerful telescope superior to any yet made, and a suitable observatory connected therewith to be made useful in promoting science. So the Board of Trustees was created, headed by Captain Richard Floyd, and the process of creating James's observatory could begin. But where do you put it? Now, they knew that high locations would be better, but James owned a lot of land. In addition to owning half of San Francisco, he owned most of the Santa Clara Valley, including what is today San Jose. He owned most of Napa Valley, including Mount St. Helena. He owned a majority of the coastline of Lake Tahoe. He owned a large ranch down outside of Los Angeles. Today you and I would call this ranch Hollywood. And he owned Catalina Island down in Southern California. So he really had fantastic taste in land. The first choice for his observatory was actually Lake Tahoe. Again, James owned most of it. And actually in this map from 1874, just at the top left there, you might be able to see the site of J. Lick's Observatory noted. But Tahoe gets heavy snowfall during the winter. James wanted his observatory accessible year-round. So, okay, Tahoe is out. Second choice was actually Mount St. Helena in Napa Valley. But James, despite owning it, was not familiar with the location. And he had originally wanted to be buried at his observatory. And he wasn't going to be buried anywhere that he was unfamiliar with. So, the trust got a wagon, put a mattress in the back of it, and loaded James into the back of the wagon. They headed up the mountain, but along the way, the wagon hit a rock or a rut. James was ejected out of the back of the wagon, and despite being unhurt, he declared that no land of his would dare treat him this way. He had the party turn around, return to San Francisco, where he promptly sold the land. It was actually his assistant, Thomas Fraser, who suggested Mount Hamilton. James could see it from his homestead in Santa Clara. He was already familiar with it. And James eventually agreed. But they did not actually own the land. It was one of the few pieces of land in Santa Clara that he did not own. And so the land was actually granted to the trust by an 1876 Act of Congress. One condition of him choosing the land, however, was that the county build a road to the top, first class in every particular. The road had to be accessible by mule carts, so it had to have a very gentle grade, so it has lots of twists and turns and switchbacks. And if any of you have ever driven up to Lick Observatory from San Jose, the road up there today still follows that same path. It's in a little better condition these days with a two-lane paved highway versus the old dirt mule cart road, but it still follows the same route. That road was completed in 1876. And here you can actually see the deed for the Lick Trust, in which James certifies that he has selected the summit of Mount Hamilton to be the site for his observatory. Unfortunately, James did not live to see his observatory constructed. Right about as they were finishing the road to the top, he passed away in 1876 at 80 years old. Now, before his death, some of his friends and the Lick Trust had suggested perhaps cremating him so that he could be interred at his observatory when it was constructed. And James simply replied, "No, sir, I intend to rot like a gentleman." So James passed away. And after his death, he actually left the bulk of his money to charitable causes. You can kind of see the distribution of his money here. He funded schools, he funded public baths. He did construct a couple of monuments to himself and his parents back in Fredericksburg. He left money to the Society of California Pioneers, which he had been the president of for many years. But the largest single donation went to the Lick Astronomical Department of the University of California, and that was $700,000 in 1876. Depending on how you do the calculation, if it's just straight inflation, that's something like $20 million today, but there was a lot less money around back then, and so as a fraction of the GDP, it's worth something like $1.9 billion today. It's an absolutely insane amount of money to leave to this single charitable cause. You'll also note that John Lick, his son, is listed here. Originally, James left him just $3,000. This was eventually increased to $150,000 and later $535,000 in an attempt to stop John Lick contesting the will. But James had wanted to basically leave him nothing. Now, in 1879, it's finally time for a site survey to determine the quality of Mount Hamilton for astronomy. Honestly, it's probably a little bit late now. The land has been given to you by Congress. You've built a road up there. What do you do if the site survey tells you it's not a good site? But they chose this man, Sherman Wesley Burnham. Now, Burnham was an astronomer from Chicago, and he was an experienced double-star observer. The idea is if you have two stars orbiting each other, if the separation of the stars is adequate, and if your observing site is good, you can discern them as two individual stars. But you can imagine if your observing site is poor, if the atmosphere blurs out the light from those stars too much, they will simply blur together and look like one single object. So Burnham was well experienced with judging the quality of astronomical sites, and he spent 60 days on top of Mount Hamilton, 49 of which were clear. And on his very first night, he discovered that Antares is actually a double star. And so you can see an example of that on the right here. This is Antares with its large, bright primary star, and then the little faint guy right next to it. That was discovered for the first time by Burnham on top of Mount Hamilton. When he was done, he described it as the best location he had ever experienced, and he stated that 42 of the 49 clear days were perfect conditions. So good news, turns out Mount Hamilton was a good site for their observatory. In 1880, they started to construct the observatory proper. To flatten the mountaintop, they used black powder and blasted about 70,000 tons of rock off the top to flatten it out. They made two discoveries that made building the observatory a little easier. They discovered mountain springs for water, so they no longer had to worry about transporting water up from San Jose, and they discovered a large clay deposit. So the bricks to construct the observatory were actually fired on site. You can see an image from the observatory's brickyard there. All in all, they were at the peak of construction, they were firing about 10,000 bricks every day, and in total, several million of these bricks were used to construct the observatory. 32,000 of those bricks were used to construct the small dome you can see on the left here. This was the first permanent structure raised atop Mount Hamilton. This other small building on the right here housed a meridian telescope. And so you can see the meridian telescope open on the right here. The idea is you have a telescope fixed looking at stars as they cross the prime meridian that runs north-south. And by observing stars as they cross the meridian, you can very, very accurately work out the time. And so Lick Observatory actually provided a timing service to the railroad in its early days as a way of getting some income in their early years. Inside the small dome on the left there, they placed a 12-inch refracting telescope. So the lens from this telescope actually came from Henry Draper's telescope in New York. Henry Draper was a very famous astronomer of his time. And so this was just kind of an off-the-shelf telescope placed into that small dome for the observatory to use while they waited for the construction of their great refractor. The first person to actually use this telescope was this man, King David Kalakaua, the last king of Hawaii. He had visited Lick Observatory during his world tour in 1881, and even though the building had not been completed at this point, if a king turns up, what are you going to do? They hurriedly erected that 12-inch refractor in the building, allowed the King of Hawaii to look through it at the night sky, and once he was done, they disassembled it again until the building was complete. In 1882, they performed some of the first scientific observations from the summit of Mount Hamilton using that 12-inch refractor. They observed the transit of Venus. So you can see here an example of one of the images of Venus from 1882. So the large, bright object here is the sun, and then at the very top, that little black circle, that is Venus, passing in front of the sun from our point of view. Now, Venus transits the sun every 120 years or so, and there are a pair of transits, each separated by 8 years. So the last pair happened in 2004 and 2012. So here is an example of the 2012 transit of Venus. Again, surface of the sun, and you can see the disk of Venus just in the top right there. If you missed this transit, like I did, I was in the UK at the time, lovely cloudy skies, it's fine, the next transit will happen in 2117. So just a little bit of waiting. Here you can see the main building under construction. Again, the small dome just on the left there. They're building this long corridor. And if you ever visit Lick Observatory, this is our visitor center today. Finally, in 1885, it's time to start the construction of their great refractor. So they contracted Alvan Clark and Sons, one of the premier lens makers of the day, but no one in the United States was experienced in making large pieces of optically pure glass. So they contracted with Charles Fay, who was a glass maker in Paris. He poured two 36-inch blanks for the lenses for this telescope, lenses 3 feet across. And then, declaring this his life's work, he promptly retired, leaving the glass business in the hands of his son. Unfortunately, one of those lenses was actually damaged in transit to the United States, and a replacement had to be constructed. Turns out the son lacked his father's talent, and he tried again and again and again to cast the replacement blank for the telescope. Finally, after 18 failed attempts, he had to beg his father to return to the business before it was bankrupted. On his very first attempt, Charles Fay successfully created the replacement blank and took the business back from his son. And there's actually an excerpt here from the scientific journal Nature at the time, celebrating the return of Charles Fay to the glass business. Finally, with a suitable piece of glass on its way to Alvan Clark in Boston, the grinding of those lenses to shape could begin. And then a year later, the largest lenses ever constructed at that time crossed the continent on a specially designed railroad car, and then made their way up Mount Hamilton in a horse-drawn carriage. You can see here a photo showing those lenses arriving on December 27th of 1886, and the caption at the bottom there simply reads, "Beautiful day." Here you can see the Captain Floyd, who was the president of the Lick Trust, holding the lens there, one of the 36-inch lenses. The telescope actually has two 36-inch lenses. They're held about 6.5 inches apart from each other. One is made of crown glass, and the other is made of flint glass, a type of leaded glass. And the idea with mixing these two different types of glass lenses together was to try to limit the effect of chromatic aberration, which is when different colors, different wavelengths of light tend to focus at different distances when you use lenses. So they placed these lenses in a very long hallway they had constructed, measured their focal length at 57 feet, so they knew these lenses would focus light, bring light to a focus at a distance of 57 feet. They finally knew how long the telescope had to be for these lenses. They could finally continue constructing the building. And those lenses were placed in a safe in the director's office to await the construction of the telescope. With construction underway on the telescope, it was time for James Lick to be reinterred. Now remember, he had wanted to be buried at his observatory, but he had died about 10 years prior to this, and he'd been buried in the Masonic Cemetery in San Francisco. So he was dug up. Members of the trust who had known him in life had to look inside the casket to confirm that it was James Lick inside, and when asked what they had seen, they responded that James had kept his final promise. He had indeed rotted like a gentleman. They actually had to sign papers to the effect that it was James Lick inside. One copy was filed in San Francisco, and one copy was placed in the casket with James when it was buried at the base of his telescope. So this is actually in the basement below the 36-inch Great Refractor at the observatory, and behind that plaque lies the casket of James Lick. You can still see that today if you go down into the basement below the observatory floor. Here on the left is an image from 1887. You can see, on the right you can see that small dome from before, and on the left is the dome for the 36-inch Great Refractor under construction. And you can see here now, later in 1887, they've begun work on the protective iron dome that would later encase the telescope. And finally, here it is. This image was taken January 3rd of 1888. You can see the Great Refractor there. First light for this telescope was actually scheduled for January 1st of 1888, but there was a blizzard. So, can't open the dome. Next day, January 2nd, the weather has abated, but they find that their lovely new all-steel dome, the very first steel dome in North America, had frozen shut. Okay, January 3rd, they managed to get the dome open, but they find it's still frozen in place. They cannot turn the dome, so it's stuck in one position. But that's fine. They wait until the bright star Aldebaran transits in front of the open dome slit, point the telescope at it, and they get their first view with the world's greatest telescope. And it's terrible. They find they cannot bring the star into focus no matter what they do. Someone had measured the focal length of those lenses incorrectly. Fortunately, Mr. Swayze, who had actually built the telescope, was there that night. He declared he knew exactly what to do. He ran off to the workshop, came back brandishing a hacksaw, and promptly cut about 6 inches off of the end of what was the world's greatest telescope. Before they could find out if Swayze had done the right thing, the weather closed in again. They had to close the dome and wait. Finally, a few nights later, on January 7th of 1888, this man, James Keeler, who was one of the original Lick Observatory astronomers, got his chance to take the first true look through this telescope. He made some observations of Saturn, and this is what he saw. So this is actually a drawing that Keeler made on that night of January 7th of 1888. And I mean, the first thing I take away from it is I'm glad I'm a modern astronomer. I have no artistic skills, so I would be hopeless. You can see the lovely drawing here. You can see the banding on the planet itself. You can see with the rings that large black gap there, and you might be able to just see, if I can find my mouse here, you might just be able to make out this fainter, let's go back, this fainter gap right at the edge here. This was a new gap in the rings of Saturn. No one had ever seen this before. James Keeler had discovered this using the 36-inch Great Refractor. As the person who discovered it, Keeler got to name it, and of course, if you're James Keeler, you name it. You would think. He names it the Encke Gap. He named it after a German astronomer, Johann Encke, who had spent many years observing Saturn, and it was someone James Keeler looked up to. He did not name it after himself, but later on, when the Voyager probe flew by Saturn on its way out of the solar system, they discovered yet another gap in the rings of Saturn that they would name the Keeler Gap in James Keeler's honor. And so you can see so you can see on the right hand side here the Encke Gap that James Keeler had discovered, and then the small gap here, the Keeler Gap, the Voyager discovered and named after James Keeler. Here you can actually see an image from the Cassini flyby of the Keeler Gap. You can see the waves in this gap that are created by the small moon. You can just see the right-hand side of the gap there. So this is a small moon of Saturn, Daphnis, that actually orbits within the rings of Saturn within the Keeler Gap.
So those waves are transient?
Yes.
Okay.
And so yeah, they're created by the moon as it moves through the rings. In 1892, this man, Edwin Emerson Barnard, finally got his chance to look through the 36-inch refractor. And when he did, he looked at Jupiter. And you can actually see an excerpt from his notebook on the left here. One thing to take away is he was not the artist that Keeler was. But you can see here, he's drawn Jupiter. He's drawn there, labeled with the number 3. He's drawn one of the Galilean moons. And just below it, he's drawn something that he's just labeled object. Underneath he says, this must be a new satellite. He had discovered the 5th moon of Jupiter, Amalthea. The first 4, the Galilean moons, were of course discovered by Galileo back in 1610, and it would take over 280 years for us to build a telescope capable of finding the 5th moon. This was also the last time anyone ever looked through the eyepiece of a telescope and discovered a new world. Everything that comes after this uses photography or other techniques like spectroscopy or astrometry. This was the last time someone ever simply looked through a telescope and discovered a new world.
Where's the eyepiece on that equipment?
So the way it's set up right now, this is set up with like a photographic equipment, but with eyepiece operations, you'd have an eyepiece coming out right at the back end here.
Okay.
But it's it's all the way at the back. The way it works, because it's a very long telescope and because the eyepiece is right at the back, it can, if you're looking down on the horizon, the eyepiece is, way up out of your reach. So the floor that Barnard is standing on there is actually a giant elevator that goes up and down so that you can reach the eyepiece wherever it may be, wherever the telescope may be pointing in the sky.
Thank you.
All good. So here, just for fun, there's a couple of images of Amalthea. So at the top is an image of Amalthea taken from the Galileo probe that flew past in 1999. And then, because it's always fun to see images from James Webb, here's an image that the James Webb Space Telescope took of Jupiter. And then on the left there, you can see Amalthea.
How large is that?
I actually don't know how large Amalthea is off the top of my head.
If it were much bigger, it would be spherical.
Right, you can see it, yeah, exactly. It tells you there is some limit because it's not spherical under its own gravity. But yeah, good question. I don't actually know. So, Lick Observatory has been at the forefront of astronomy since its founding, but the story doesn't end with the construction of the Great Refractor. That was really the beginning of the story of Lick Observatory. The Great Refractor is actually still used every summer for our public programs. It's no longer used for science, but every summer we have groups of visitors come up and get to look through this telescope, joining these ranks of famous astronomers. Lick Observatory has made contributions to science. You know, we've already talked about the discovery of the gaps in the rings of Saturn and the discovery of Amalthea. It was astronomers at Lick Observatory who contributed to showing that there was a wonderful theory in the late 19th and early 20th century that some astronomers thought they saw evidence of canals on the Martian surface, and they took this as evidence of an advanced civilization on Mars. But it was actually Lick Observatory astronomers who showed that these were simply optical illusions. It was dust collecting along unresolved mountain ridges. There were no canals. There were no Martians. We made the first measurement of an active galactic nucleus. That is a black hole at the center of a galaxy. We found evidence for galactic dark matter showing that galaxies were rotating faster than they should if there was simply gravity and stars holding these things together. So we're going to talk through now some of the telescopes and science that came to Lick Observatory in later years. So here we have one of my favorite telescopes on the mountain, at least in its current incarnation. This is the Crosley telescope, and I love this telescope because, just like me, it did not start out life here in the United States. It was actually built in the 1870s in England by a gentleman named Andrew Ainsley Common. And so it's a 36-inch telescope, but it is a reflector telescope. So it uses a mirror to focus its light. It was by no means the first reflecting telescope. They did exist at the time, but all of the reflecting telescopes back when this one was built used metal for their mirrors. They used a metal called speculum. It's an alloy of tin and copper. You can polish it up to become very, very reflective, but it tarnishes very quickly and it's very, very soft. So when you made mirrors out of this, you would find they would tarnish very quickly, lose their reflectivity, you'd have to polish them, you'd inevitably change the shape of the mirror, and you'd have to refigure and reshape the entire mirror of your telescope. Andrew Common, when he was building his 36-inch reflector, did something different. He used glass to make his mirror. He took a piece of glass, ground it into the shape that he wanted, and coated it with a thin layer of silver to make it reflective. These days, that is how every large telescope around the world is built. You take a piece of glass, grind it into the shape that you want, coat it with something reflective, usually aluminum these days, but we still use silver depending on what wavelengths, what colors of light we're looking at. Or if you're the James Webb Space Telescope, you use gold, because they're looking in the infrared. But this really is the grandfather of every major telescope around the world today. So it started out life in England. It was eventually donated to Lick Observatory in 1895. And when the astronomers at Lick finally got their hands on it, they declared it a pile of junk. You can kind of see from this image, the telescope in its original incarnation was very spindly. It would bend and flex under its own weight as you moved it around the sky. It did not track the stars well. They did not enjoy using it. It was eventually rebuilt and upgraded to a much more solid structure. This is the Crosley as it exists today. And it would eventually go on to become the workhorse of California studies of spiral nebulae. So back in these days, we did not know the nature of these objects. But today, you and I would call these objects spiral galaxies. And so James Keeler was at the forefront of studying galaxies outside of our own. He took a lot of images with the Crosley telescope. Here's just one example of him taking images of the Orion Nebula. But he was very interested in nebulae. So here's an example of his Orion Nebula. And here's a spiral nebula. So this is Messier 51, or what we would call today the Whirlpool Galaxy. But Keeler spent a lot of time taking images, taking photographs of these nebulous objects in the night sky. Here's another example of a long exposure here. You can see in the center there, this edge-on galaxy. But James Keeler started to notice that whenever he took these images of these spiral nebulae, these nebulous objects in the night sky, he would always see more and more of these things in the background, especially when he was pointing away from the plane of our own galaxy. If he looks outside, away from the plane of our galaxy, he would start to see more and more and more of these objects. And he started to realize these must be objects outside of our own galaxy. He went as far as constructing a low-resolution spectrograph to use with the Crossley telescope, but just 2 weeks after finishing it, he passed away in 1900 at the age of just 42. He was very young, and he was right on the cusp of starting to study and understand these galaxies. He was actually about a decade ahead of his contemporaries like Edwin Hubble at the time. And so the running commentary at Lick, at least, is that had James Keeler lived, we would probably have the Keeler Space Telescope today instead of the Hubble Space Telescope, simply because he was so far ahead of everyone in the field at the time. In the 1940s, Lick Observatory constructed the telescope that lives inside this dome, the Carnegie Dual Astrograph. So the idea with an astrograph is it's a type of telescope that is engineered to have a very, very flat focal plane, and that lets you very, very accurately measure distances on the night sky. And so the dual astrograph here is actually two telescopes mounted side by side. You can see one at the forefront and then the other sitting just behind it. These are both 20-inch refractors. And then at the back end here, you can see this large, square wooden box. This is one of the photographic plate holders. So into that they would place one of their glass photographic plates. These were very large pieces of glass, about 17 inches by 17 inches, covering an area on the sky of 6 by 6 degrees. And to give you some frame of reference, the full moon is about half a degree across. So, you know, one picture from this thing would cover an area on the sky of 12 full moons by 12 full moons. They were massive. Right. And so these were designed to do an all-sky survey to photograph the entirety of the sky that was visible from Lick Observatory. And the idea was actually to do that twice, separated by about 25 years. And by doing that, you can measure what is called the proper motion of the stars. You can measure how the stars move in the 25 years between your different pictures. But if you're the Lick Observatory astronomers, you're not just going to sit around and wait for 25 years to do your science. So it turns out, when you take an image of the night sky and you're looking for those nice stars, you also end up getting a bunch of galaxies in the background. And so two Lick Observatory astronomers, Shane and Wertman, spent about 50 years clumped together into this kind of spiderweb-like structure. And if you compare their measurements to modern cosmological simulations performed on supercomputers, you can kind of see they really were making the first measurements of this kind of structure of the universe. In the 1950s, the then director of the observatory, Donald Shane, decided we needed a new large telescope. We were falling behind. The largest telescope at that time was still the 36-inch Great Refractor that we've spent all this time talking about, built in 1888, and the 36-inch Crossley that had been built in 1875. So he decided we needed a new large telescope, and he had us construct what is today called the Shane telescope. This is a 120-inch reflector, or 3-meter reflecting telescope. So the mirror that sits at the base of this telescope underneath this protective cover is 120 inches or 3 meters across. At the time of its construction, when it saw first light in 1959, it was the second largest telescope in the world. It was actually second only to the 200-inch Palomar Hale telescope down in Southern California, and it actually owes its existence to the Palomar telescope. The glass for this mirror is actually a test blank that they had cast for Palomar when they were constructing that in the 1940s. They were using Pyrex glass to make the mirror, and Corning Glassworks actually didn't know if they could make a 200-inch piece of glass for Palomar, so they made, among other test pieces, they made a 120-inch test piece that would later go on to form the heart of the Shane telescope. These days, it's more like mid-40s in terms of telescope size. We've built a lot of large telescopes in recent decades. But it was actually the Shane telescope that was used as part of the NASA Apollo missions in the 1960s. So in 1969, when we landed on the moon, Buzz Aldrin and Neil Armstrong deployed, among other things, a retroreflector on the lunar surface. And the idea with a retroreflector is it reflects light back along the path it comes in on. And so NASA actually came out to Lick Observatory, installed a couple of giant ruby red lasers, the most powerful lasers anyone would admit to having at the time. Those lasers were fired at the moon, they reflected off the retroreflector, were detected again at Lick Observatory, and by very accurately measuring the time it takes for the laser light to travel to the moon and back, you can very, very accurately work out the distance. That was first performed at Lick Observatory just 4 days after the astronauts landed on the moon. It continues today at McDonald Observatory in Texas and Apache Point in New Mexico. The Shane was also pivotal in developing adaptive optics technology. And so the idea with adaptive optics is Earth's atmosphere really gets in the way. It blurs out light from whatever you happen to be looking at and limits the effective resolution of your telescope. But by looking at a bright star, measuring the shape of it thousands of times a second, you can actually measure the turbulence in the Earth's atmosphere, and using small, movable mirrors, you can correct for that turbulence. And if you do that, you can effectively correct for the Earth's atmosphere. And if you do that, you get something like this. So on the left here is an image of Uranus taken without adaptive optics. And you can see the planet, you can even see the rings around it. You can see a little moon there off to the bottom. But if you turn on adaptive optics and you start correcting for the Earth's atmosphere, suddenly everything comes into nice, sharp focus. You can see the planet, you can see the rings, you can even see gaps in the rings, and then you can see those bright spots on the surface of Uranus. Those are storms. We can start to measure the weather on other planets. And so here's an example image taken in 2014 of Uranus with the adaptive optics system on the Shane telescope. There is a ring around it. It shows up on my laptop screen, not so great on the projector. But more importantly, on the surface there, you can see those bright storms on the surface. And so there's actually an ongoing program at the Shane to monitor these storms over time and see how.
Like lightning?
So yeah, effectively it's you're yeah.
Okay.
But you're able to track how these things are changing over time. In the 1970s, we finally replaced this telescope, the small 12-inch refractor, with a modern 1-meter or 40-inch reflecting telescope. This is the Nickel telescope. It's named after Anna Nickel, who was a seamstress in San Francisco. She left about $50,000 to the observatory in her will to fund the construction of a new telescope. And we don't actually know what her connection to the observatory was. No one knew who she was, and then she left all of this money to the observatory in her will. But we used it, we built a brand new telescope and named it after her. This telescope these days is mainly used for supernova study, so tracking the remnants of exploding stars, largely in other galaxies, and seeing how they change over time as they dim. It's also heavily used for technology development, which we'll mention a little bit later.
What happened with the old telescope?
So the old telescope is actually still in storage on campus at UC Santa Cruz, and the idea is eventually to refurbish it. A nice one-day pipe dream is it would be great to move this telescope elsewhere on the mountain and restore the 12-inch to its original dome. But it does still exist. It's being refurbished and rebuilt because it's in poor condition after such a long period of time.
Yeah.
In the late 90s, the first robotic telescope at Lick Observatory saw first light. So this is the Katzmann Automatic Imaging Telescope, or Kate. And so Kate is a 30-inch reflecting telescope that is fully robotic. So any given night, if the weather is clear, it will automatically open up, go and point at a target from its list of targets, and spend the night taking images. And this telescope was designed to look for supernovae. So the idea is it looks at a bunch of galaxies, night after night after night after night, looking for a new bright star in those galaxies. It's looking for a new supernova. Before Kate came along, all of the astronomers in the world combined discovered maybe a couple of dozen supernovae every year. When Kate came online, it very quickly started discovering 1 to 2 supernovae every week. It quickly outclassed the entire rest of the field combined, and was pivotal to revolutionizing our knowledge of cosmology. So this is used heavily by Alex Filipenko at UC Berkeley. He was actually the one who designed and built it. And so this was pivotal as part of the work that would later go on to earn him and his team the Nobel Prize. In 2013, we got another robotic telescope. This is the Automated Planet Finder, or APF, and the name kind of gives the game away. It's a 2.4 meter telescope, and it is designed to look for planets. It is designed to look for planets around other stars, or extrasolar, or exoplanets. It does this using the radial velocity method. So you take a spectrum of your star, you effectively spread its light out into its component wavelengths or component colors, and you can actually measure the motion of the star, measure the velocity of that star by how the lines in that spectrum shift as the star moves away or towards you. And the idea is that if you have a star with a planet going around it, they actually orbit their common center of mass. And so as the planet goes around, the star will actually wobble slightly back and forth, and you can measure that motion from here. That motion is usually small, because of course planets are much, much smaller than their host star, but it is measurable. And so you can start to find stars around other planets. The APF has a very, very sensitive spectrograph, and it's also fully robotic. It's automated. So it doesn't get bored staring at the same stars night after night after night after night. It's discovered
Do the planets have to be Jupiter-sized or bigger?
So the idea with the APF was that eventually they would be able to push down to something more like Earth-sized. But to do that, you need a lot of data over a long time, because you can imagine, so if you have a planet like the Earth, we go around our star once a year. So you need at least 1 year's worth of data to see even like one little bit of motion from the star. And realistically, you need many, 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 many years of data combined to have a true measurable signal. And so the APF was designed to start probing down to those smaller planets. Now it's not actually realistically going to reach Earth size, but it was designed to reach a lot closer to Earth-sized planets than, say, the Jupiter-sized planets that we were detecting at the time. So it has been involved in the discovery at this point of dozens of planets. Here's one example, an artist's interpretation of one of the planet systems it discovered. This is the Levy exoplanet system. It's a triple planet system orbiting a bright star. But it's been involved in the characterization of hundreds of planets at this point. In 2020, while the pandemic was at its height, we deployed another new instrument at Lick Observatory, PEAS. So PEAS stands for the Planet as Exoplanet Analog Spectrograph, and the idea is it looks at planets in our own solar system, especially the large ones, Jupiter, Saturn, Uranus, using the same techniques we use for planets around other stars for these exoplanets. Because of course we can visit the planets in our solar system, we can send probes, we can make direct measurements, which you can't do for planets around other stars. And so PEAS is designed to look at the planets in our solar system that we know a lot more about, use the same techniques that we use for exoplanets, and find out if the things we're doing, the techniques we're using for exoplanets, produce the correct results. Also in 2020, SETI, the Search for Extraterrestrial Intelligence, deployed their new PanoSETI telescope at the observatory. The idea with PanoSETI is it's a very, very fast photo detector. It's designed to look for short pulses of laser light coming from other stars. The idea is lasers do not occur naturally, so if you see laser light coming from another star, it's a prime indicator of intelligent life using lasers for communication. They actually have, you can see here, so this is actually the dome that houses the dual astrograph that did that all-sky survey. That telescope is no longer used, but now instead mounted at the front of the dome there are these two PanoSETI telescopes side by side. They use two because if you see one event in just one telescope, it could be an error. If you see it at the same time in both telescopes, it's likely a real event. And this is kind of what data from that telescope looks like. They were using one of NASA's LiDAR telescopes. It uses lasers to measure clouds and aerosols. They observed that as it went overhead and were able to observe it in both telescopes. But it turns out these telescopes, despite being designed to look for laser light, they're also really, really sensitive to Cherenkov radiation, which is the radiation generated by high-energy particles when they hit our atmosphere and slow down. So they're great for gamma-ray astronomy. And so in 2022, they went out to the Veritas Gamma-Ray Observatory in southern Arizona, set up a couple of their telescopes. You can see the two PanoSETI telescopes here, and then the large gamma-ray telescope in the back there, the large Cherenkov telescope of Veritas. And they made observations of the Crab pulsar at the center of the Crab Nebula. And then last year, in 2024, they deployed a couple of new telescopes at Lick Observatory, all linked together by fiber optics, that was simultaneously looking at the Crab pulsar at the center of the Crab Nebula. So despite being funded and built by SETI to look for signs of intelligent life, these telescopes are now doing active, novel science. In 2023, we deployed a new laser system. Lawrence Livermore Labs deployed a new ultraviolet laser system at the Nickel telescope, designed to be used with its with an adaptive optics system there to do very, very fast adaptive optics corrections of visible optical light. So it is being used as a test bed right now for brand new technology. We actually have a brand new science camera being deployed at the Nickel telescope on Tuesday. And then later this year, we are deploying a new laser guide star system at the Shane telescope. So, the one thing I really want you to take away is the story of Lick Observatory did not end with the construction of the 36-inch refractor in 1888. Science continues today. We are still developing new technology. We're still pushing the boundaries of scientific knowledge. And we know who to thank for all of this, right? Henry Snavely, the miller from Stumpstown, Pennsylvania, who made this man, James Lick, so bitter and petty, he held on to a grudge for decades, went away to become the wealthiest man in California, and left the bulk of his fortune to charitable causes. So yeah, that is the end of my talk. I will leave it there, but if anyone has any questions.